Hey, hello everyone. Welcome to the discussion of LeetCode Biweekly Contest 171. Let's start with the first problem. The first problem states that we are given an integer num. Number num is called coprime complete if every prefix and every suffix of num is prime. For example, this num, the first prefix is 2, which is prime, and the second prefix is 2 3, which is prime itself. And if we see the suffix, then the first suffix is 3, which is prime, then the second suffix is 2 3, which is prime. So the answer is true. If at any procedure, like any prefix or any suffix, we come to observation that that prefix is not a prime or that suffix is not a prime, then we just return false. All right. So it's an implementation problem. What do we need? We need a function which returns if a number is prime or not. Do it for all the possible prefixes and suffixes. What are the constraint of maximum number of prefixes we need to check? That is 9, because we can represent our number up till 10 to the power 9 using at max 10 digits. So iterate over all the digits. So at max 10 times 2, that is 10 prefix and 10 suffix. So total 20 computations or 20 operations to check. So just take a number and iterate from. So to check if a number is prime or not, start right. Just write the normal function to check if a number is prime or not. If it has a factor, then return false, else return true. Now, one edge case, n equals 1 is a prime number, non-prime number. All right. Now, uh, we need to check this function's validity for all the prefixes and suffixes. So let's use string for easier computations. Convert the number to string. Now check the validity of this function for all the prefixes. If this function fails for current prefix starting from 0 and size I plus 1, then return false because we got a non-prime number in this prefix. If the function fails, there is prime for string from this to this and then convert that string to a number. All right. Now this suffix starting from I up till n, if this condition do not hold, just return false. Okay. So this is it. The solution is passed. Let's move to the second problem now. The second problem says that for a given integer array nums, for each element nums at I, you can perform the following operation any number of times. Increase num at I by 1 or decrease num at I by 1. A number is called binary palindrome if its binary representation without leading zeros read the same way forward or backward. Now our task is that we are given an array of numbers. Now we need to convert each of the number into a binary palindrome using these operations: increase by one or decrease by one. Like uh, so, let's understand what the problem says. Problem says that we are given a list of numbers. Let's say uh, 5, 6, 7, 8 for all these numbers. Write its binary representation. For example, 5 is represented by this. Now, you can either add 1 or subtract 1 in each operation, and you need to make the binary representation of all the numbers a prime, a palindrome. Like for 6, it is this. Now, to make palindrome, you need to change this particular index to 1. All right. So, what do we need? Let's say at an index we got this number. So what do we need? The last half should be equal to first half. All right. So iterate over the last half. Let's say for a so what does the problem says? Problem says to check each of the numbers in nums array. What is the minimum number of operations required to convert each of these numbers into a binary palindrome? All right. Now what is the constraint? We are given at max 5,000 numbers, and uh, the constraint on each number is up till 5,000. Okay, so let's uh, try to calculate what is the closest number to 5,000 that is a binary palindrome. All right, closest number above 5,000. Okay, what can it be? The like let's say what is the MSB of 5,000? 5,000 can be represented in, I guess, at max. Let's find it out. Uh, log of 5,000 base 2. It is approx 13 bits. All right. So if we just increase the bit, that is, let's say 5,000 was represented like this. All right. Now, if we convert this into all ones, what is the minimum number of operations required? Because this in itself is a binary string. So what is the minimum number of operations required for this? The minimum number of operations can be at max 2 to the power 2 to the power 13 itself, which is approximately 5,000. So at max in 1,000 10,000 operations, at max, or 5,000 operations only, we can find out. Okay, at max in 10,000 operations, we can find out what is the closest number above uh, 5,000, which gives us a binary palindrome. Similarly, if we what is the lower bound? 0 in itself is a binary palindrome. So if we are given 0, we need 0 operations to find the lower bound. So if we are given a number in between 0 and 5,000, what is the upper bound? The upper bound is this 5,000 and the time taken to reach this particular string, or cost taken to reach this particular string. If the lower bound is required, then what is the minimum number of operations required? It is again 10,000 or 5,000, because let's say 5,000 is given, and worst case we go up till 0, so 5,000 operations is needed. So in at max 10,000 operations, we can find out the lower bound and upper bound for each given number. And what are the number of strings given to us? They are uh, 10 to the power 3. So it's very much computable, and we know that this is the upper bound and lower bound. The real answer will always be much smaller than this. So let's just write down brute force score, because it seems optimal. it seems to run optimal in this scenario. So what does the problem require? It requires us to iterate over, needs us to create a answer array which finds the minimum number of operations required to convert a given number to binary palindrome. Now for a given number, take cur as num. Now while the current number is not binary palindrome, let's say we want binary representation. So another function binary of cur. What do we do? We just increment cur by 1. At the point we find that uh, this is the required number, then our answer will be minimum of answer comma the number of operations done now, which is cur minus num. All right. Let's take answer as int max in the beginning. In the second case, we do the same operation but for negative sign. Okay, let's take this as operations required vector. Then opn dot push back the minimum number of operations required for current string. At the end, return opn. All right. Now these two functions that we just defined but did not create. For the first one was binary function. It takes integer input and gives string output. That is the binary representation of a number. Binary palindrome. Now divide the size by 2. Check for the later half with same distance. If it is not same, then it is not a binary palindrome. This is it. Let's submit. Now let's move to the third problem. Now let's move to the third problem. The problem says that we are given two integer arrays, technique 1 and technique 2, each of length n, where n represents the number of tasks to complete. Now for ith task, it can be done using unique technique 2 or technique 1. Using technique 1, we earn technique 1 at I points, and using technique 2, we earn technique 2 at I points. Now there is a constraint that we must do at least k tasks from technique 1. So we must compute the maximum total number of points we can earn by computing at least k tasks using technique 1. The rest we are independent to use either technique 1 or technique 2. So let's have a construction for this. What do we have? We want to have, let's denote technique 1 as T1 and technique 2 as T2. So for T2, for T1, we must have at least K. For T2, we must have we must have uh, those points for the rest points, rest choice independent of T1 and T2. So let's have a construction. Let's say we chose all the points from T2 right now. Okay, so let's say T1 T2 was having some numbers like this, represented by some space gap. Now we have some sum. This sum represent uh, points after all gain from T2. Now we want to choose at least k points from T1. After this construction, since we have chosen all the points from T2, if we choose a point from T1, now what happens? How the sum changes? Now sum is having, let's say we choose T1 at I. So T1 already has the contribution due to T2 at I. So we need to subtract it. Alright. And a new term of contribution due to T1 at I will be added. Alright. So the sum changes like this. So if this particular thing is positive, it is very likely for us to take it because it maximizes our sum. Alright. Sum was the maximum number of points we can gain using either T2 or either T1. And if it minimizes or it is less than 0, if it is less than equal to 0, less than 0, then we have an additional constraint. Like if already k elements chosen, then just stop because it's no use to take this point because it minimizes or subtracts something from our sum. Stop or no need. If it is the condition that uh, less than k element has been chosen, then we need to take it. All right. Now we want this to be the best possible scenario. That is, we take the best T1s. So take a vector which contains only T1 at I minus T2 at I and sort it in reverse order. So we get the best values of T1's choice at first and select any k of them. All right. Or if the value is still greater than 0. Okay. And if the value is less than 0, if the value is still greater than 0, then keep on taking it until and unless the value comes until negative. So let's implement it. So what do we have? We have two vectors, technique 1 and technique 2. Initially, let's shorten it, name it T1 and T2. Initially, answer is equal to all the points of T2. Now create a vector. Vector contains of all of the let's keep on pushing T1 at I minus T2 at I. Now sort in reverse order. Now keep on taking the elements and updating our answer value with following conditions. First of all, I should be smaller than it because we cannot exceed the limit. Now, if I is smaller than k, then we must take it. So the second condition will be or. Like if I is smaller than k, then go forward. No need to check other conditions. Just take it. The second condition is if uh, the loss function or vec function is greater than equal to 0. Alright. Then we will take this point. What do we do? Answer plus is equal to vec at I. Alright. Now at the end, just return answer. Okay, alright. The answer must be written in long. So convert it to long. This is it.